క్యారియర్ సెన్స్ మల్టిపుల్ యాక్సెస్. ఇది సిఎస్ఎంఏ వచ్చేసి ఒక క్వశ్చన్ అడిగినాడు ఇస్రోలో. విచ్ ఆఫ్ ద ఫాలోయింగ్ ట్రాన్స్మిషన్ మీడియా ఈజ్ నాట్ రెడీలీ సూటబుల్ ఫర్ సిఎస్ఎంఏ ఆపరేషన్? రేడియో, ఆప్టికల్ ఫైబర్స్, కయాక్సికల్ కేబుల్, ట్విస్టెడ్ పేర్. రేడియో వేవ్స్ సూటబుల్ కాదు. అసలు సిఎస్ఎంఏ అంటే ఫుల్ ఫామ్ కూడా ఏమి ఇవ్వలేదు. సిఎస్ఎంఏ అంటే క్యారియర్ సెన్స్ మల్టిపుల్ యాక్సెస్ is a method used in a computer networks to manage how devices share a communication channel to transfer the data between two devices. In this portal, each device first sends the channel before sending the data. If the channel is busy, the device waits until it's free. Okay, communication channel to transfer the data between two devices. ఒక నెట్వర్క్ ఇది మెథడ్ వచ్చేసి కంప్యూటర్ నెట్వర్క్స్లో ఒక డివైజెస్ కమ్యూనికేషన్ ఛానల్ బిట్వీన్ డేటా ట్రాన్స్ఫర్ ద డేటా బిట్వీన్ టూ డివైజెస్. రెండు డివైజెస్ మధ్యలో డేటాను ట్రాన్స్ఫర్ చేయడానికి యూజ్ చేస్తాం. ఈ ప్రోటోకాల్లో ఈచ్ డివైస్ ఫస్ట్ సెన్స్ ద ఛానల్ బిఫోర్ సెండింగ్ ద డేటా. సెన్స్ ద ఛానల్ అంటే వేరే డివైస్ ఛానల్ని ఫస్ట్ సెన్స్ చేస్తుంది డేటాని పంపించే ముందు. ఒకవేళ ఛానల్ బిజీగా ఉంటే అది ఫ్రీ అయ్యే వరకు, బిజీగా ఉన్న ఛానల్ ఫ్రీ అయ్యే వరకు వెయిట్ చేస్తుంది. దిస్ హెల్ప్స్ ఇన్ రెడ్యూస్ ద కొలిజన్ తగ్గించడానికి కోసం ఇట్లా వెయిట్ చేస్తాం. వేర్ టూ డివైజెస్ సెండ్ డేటా అట్ ద సేమ్ టైమ్ ఎన్షూరింగ్ స్మూతర్ కమ్యూనికేషన్ అక్రాస్ ద నెట్వర్క్. రెండు మధ్యలో స్మూత్ కమ్యూనికేషన్ జరగడానికి సిఎస్ఎంఏ ఈజ్ కామన్లీ యూజ్డ్ టెక్నాలజీస్ లైక్ ఇథర్నెట్ అండ్ వైఫై. వైఫై దగ్గరనే సిఎస్ఎంఏ వాడతారు. దిస్ మెథడ్ వాజ్ డెవలప్డ్ టు డిక్రీజ్ ద ఛాన్సెస్ ఆఫ్ కొలిషన్ వెన్ టూ ఆర్ మోర్ సెషన్స్ స్టార్ట్ సెండింగ్ దేర్ సిగ్నల్స్ ఓవర్ ద డేటా లింక్ లేయర్. క్యారియర్ సెన్స్ మల్టిపుల్ యాక్సెస్ రిక్వైర్స్ ద ఈచ్ సెషన్ ఫస్ట్ చెక్ ద స్టేట్ అండ్ ద మీడియం బిఫోర్ సెండింగ్. వాట్ ఈస్ వర్నబుల్ టైమ్ ఇన్ సిఎస్ఎంఏ? సిఎస్ఎంఏలో ఒక వర్నబుల్ అంటే వీక్గా ఉండే టైం ఏంది? వర్నబుల్ టైమ్ ఈజ్ ఎ షార్ట్ పీరియడ్ వెన్ దెర్ ఈజ్ ఏ ఛాన్స్ టు ద టూ డివైజెస్ ఆన్ ఏ నెట్వర్క్ మైట్ సెండ్ డేటా అట్ ద సేమ్ టైమ్ అండ్ దిస్ కాజెస్ కొలిజన్. టూ నెట్వర్క్స్ వచ్చేసి ఒకేసారి ఒకే నెట్వర్క్లో ఉన్న టూ డివైజెస్ ఒకదాంతో ఒకటి ఒకేసారి కమ్యూనికేట్ చేయడం వల్ల ఏర్పడచ్చు. The networks like Wi-Fi or Ethernet devices first listens to this, see if the network is clear before sending the data. However, after a device checks and finals the network free, there is a small delay before it starts sending data. During this time, another devices might also try to send data, which can lead to both data packets crashing into each other's a collision. This period where a collision might happen is called vulnerable time. Vulnerable time అంటే propagation time అన్నమాట. ప్రాపగేషన్ టైం ఏంది? అక్కడి నుంచి ఇక్కడికి వచ్చి ఇక్కడి నుంచి అక్కడికి వెళ్ళేది ప్రాపగేషన్ టైం, అంతేనా? వర్నబుల్ టైమ్ ఈజ్ ఈక్వల్స్ టు ప్రాపగేషన్ టైం. ఏ నుంచి డీకి వెళ్ళాలంటే బీని సెన్స్ చేయాలి, సిని సెన్స్ చేయాలి, ఇది ప్రాపగేషన్ టైమా? ద పర్సిస్టెన్స్ మెథడ్స్ కెన్ బి అప్లైడ్ టు ద హెల్ప్ ద స్టేషన్స్ టేక్ కేర్ వెన్ ద ఛానల్ ఈజ్ బిజీ ఆర్ ఐడియల్. Types of CSA protocol. Carrier sense multiple access protocols, each designed to handle how devices manages potential data collisions on the shared communication channel. There are these different types on how they respond to the detection of a busy network. CSMA CD, CSMA CA. Carrier sense access multiple carrier sees multiple access with
Carrier sense in the
Carrier sense multiple access with collisions detection. CSMS or CD is a method as a station monitor the medium after it sends a frame to see if the transmission was successful. If successful, the transmission is finished. If not, the frame is sent again. ఓకే, ఇక్కడ నుంచి ఏం జరిగింది? సి దగ్గర కొలిజన్ అయిందా? కొలిజన్స్ అక్కర్స్ హియర్. ఓకే, ఆ నుంచి సి నుంచి T4 టైంలో ఇక్కడ కొలిజన్స్ జరుగుతుందన్నాడు. ఎట్లా అర్థం కాకుంటున్నాను. కొలిజన్ అక్కర్స్ హియర్ అంటే ఇట్లా వచ్చింది. In the diagram, start sending the first bit of the first frame T1 and since C sees the channel ideal at T2 దగ్గర C అనేది ఐడియల్ ఉంది. స్టార్ట్ సెండింగ్ ఇట్స్ ఫ్రేమ్ అట్ టీ టూ టైంలో దాని ఫ్రేమ్ని సెండ్ చేయడం మొదలెట్టింది. సి డిటెక్ట్స్ ఏ ఫ్రేమ్స్ అట్ సి వచ్చేసి ఏ ఫ్రేమ్ని టీ3 టైంలో డిటెక్ట్ చేయడం మొదలెట్టింది. అబ్స్ట్రాస్ ట్రాన్స్మిషన్స్ ఏ డిటెక్ట్స్ సి ఫ్రేమ్ అట్ టీ4 absorbs a transmission time for a C frame is therefore T3 to T2 and for A's frame is T4 to T1. సరిగ్గానే అర్థం కాలేదు. సో ద ఫ్రేమ్ ట్రాన్స్మిషన్ టైమ్ TFR should be at least twice the maximum propagation times. This can be deduced when the two stations involved in a collisions are maximum distance apart. The entire process of collisions detections can be explained as follows. Start k is equals to 0. Apply one of the persistent methods, one persistent, persistent. అది ట్రాన్స్మిషన్ డన్, కొలిజన్ డిటెక్టెడ్, ఎస్. అప్పుడు కొలిజన్ డిటెక్టెడ్, నో సక్సెస్, సక్సెస్ఫుల్గా వెళ్తుంది కదా. ఒకవేళ కొలిజన్ కనుక డిటెక్ట్ కాలేదు అంటే ట్రాన్స్మిట్ అండ్ రిసీవ్, ట్రాన్స్మిట్ చేసుకుంటుంది, రిసీవ్ చేసుకుంటుంది. కొలిజన్ డిటెక్టెడ్, ఎస్ నో అంటే సక్సెస్ఫుల్గా వెళ్ళినట్టు, ఎస్ అంటే సెండింగ్ ఏ జామింగ్ సిగ్నల్. k is equals to k+1, k is greater than max, yes అంటే about, no అంటే choose the random number r between 0 to 2 power k-1, wait tb time. Throughput and efficiency. The throughput CSMA or CD is much greater than pursue the slotted alert. For one persistent method throughput is 15 when G is equals to 1. For the non-persistent method throughput can go up to 90%. Carrier sends multiple access with the collisions avoidance. CMSMA or CA. The basic idea behind the CSMA or CA. Collision avoidance. ఇందాక collision detection CD, collision avoidance CA. The basic idea behind this carrier sends multiple access collision avoidance is that the station should be able to receive while transmitting to detect a collision from different stations in wired networks. If a collision has occurred, then the energy of the received signal almost doubles and the station can sense the possibility of the collisions. In the sense of wireless networks, most of the energy is used for transmission and the energy of the received signal increases by 5 to 10%. If the collision occurs, it cannot be used by the station. The sense collisions, therefore CSMA or CA has been specially designed for the wireless network. These are the three types of networks and strategies. Interframe space IFS. When a station finds the channel is busy, it sends the channel again. When the station finds a channel to be idle, it waits for a period of time called IFS time. If IFS can also be used to define the priority of a station or a frame. Higher the IFS, lower its priority. Connection window. It is the amount of time divided into slots. A station that is ready to send frame chooses a random number of slots as wait time. Acknowledgements. The positive acknowledgement and timeout timer can help guarantee a successful transmission of the frame. Characteristics of CSMA or CA. Collision avoidance. Carrier sense. The device listens to the channel before transmitting to ensure that they are not correctly in used by another device. Carrier sense అంటే ఇప్పుడు ఫస్ట్ అది ఏం చేస్తుంది, వేరేది ఏం చేస్తుంది అని ఫస్ట్ వింటుంది పంపించేటప్పుడు. Multiple access. Multiple devices share the same channel and transmit simultaneously. ఒకేసారి సైమల్టేనియస్ అంటే ఒకేసారి ట్రాన్స్మిట్ చేసుకోవడం వేరు డివైజెస్ అని అనుకుంటా. Collision avoidance. If two or more devices attempt to transmit at the same time, a collision occurs. CSMA carrier sense multiple access. Collision avoidance uses random back of time intervals to avoid collisions. Random backouts అంటే ఇప్పుడు పంపించాలి అని అనుకునే దాన్ని ర్యాండమ్గా వేరే టైంకి పంపిస్తుంది. అదే అనుకుంటా ఇక్కడ ఉండేది, చెక్ చేయడానికి ఇక్కడ సెట్ చేసేయడానికి ట్రై చేసేది అదే అన్నమాట. Acknowledgement. ACK. After successful transmission, the receiving devices sends an is equal to confirm receipt fairness. The protocol ensures that all devices have equal access to the channel and no signal devices monopolizes it. Binary exponential backoff. If a collision occurs, the devices waits for a random period of time before attempting to retransmit. The backoff time increases the exponentially with the each transmission attempt. Interframe spacing. The protocol requires a minimum amount of time between the transmission to allow the channel to be clear and reduce the likelihood of collisions. RTS or CTS handshake. In some implementation, a request to send RTS and clear to send CTS handshake is used to reserve the channel before transmission. This reduces the chances of collision and increases the efficiency. Wireless network quality. The performance of CSMA or CA is greatly influenced by a quality of wireless network, such as the strength of the signal interference and network cognization. Adaptive behavior. CSMA or CA can dynamically adjust its behavior in responses to changes in network conditions, ensuring the effective uses of channel and avoiding conjunction. Overall, CSMA or CA balances need for efficient use of the shared channel with the need to avoid collisions, leading to reliable and fair communication in a wireless network. Process. The entire process of collision avoidance can be explained as the following. Start k is equals to 0. ఐడియల్ ఛానల్ ఎస్. ఒకవేళ ఛానల్ ఐడియల్గా ఉంటే ఎస్, లేదనుకో మళ్ళీ రివర్డ్ అయ్యి ఛానల్ ఐడియల్గా ఉందా లేదా అని చెక్ చేస్తుంది. ఇది ఒక లూప్లో జరుగుతూనే ఉంటుంది. ఛానల్ ఐడియల్గా ఉంటే వెయిట్ ఐఎఫ్ఎస్ టైం. వెయిట్ ఐఎఫ్ఎస్ టైం అంటే ఏంది? ఇప్పుడు ఐఎఫ్ఎస్ టైం అంటే interframe space. When a station finds channel is busy, it sends the channel again. ఓకే, అంటే ఫస్ట్ ఛానల్ ఐడియల్గా ఉందా లేదా అని చెక్ చేయడమే కదా, మళ్ళీ దానికి ఛానల్ బిజీగా ఉందా లేదా అని చెక్ చేయడం ఎందుకు? సరే, అక్కడ మళ్ళీ ఎస్ఎన్ఐఎం రాలేదు కదా, దాని నుంచి మళ్ళీ స్టిల్ ఐడియల్గా లేదు అంటే మళ్ళీ ఎన్నికి పంపిస్తుంది పైన ఛానల్ ఐడియల్గా ఉందా లేదా అని. అంటే ఒక ఛానల్ ఐడియల్గా ఉందా లేదా అని చెక్ చేయాలి అంటే దాని ఐఎఫ్ఎస్ టైం చూడాలి, బిజీగా కాదా అని. ఎందుకు ఎన్నిసార్లు చేయాలా? చూజ్ ఎ ర్యాండమ్ నెంబర్ ఆర్ బిట్వీన్ 0 and 2^k-1. వెయిట్ ఆర్ స్లాట్స్. సెండ్ ఫ్రేమ్. వెయిట్ టైమ్ అవుట్. తర్వాత అక్నాలెడ్జ్మెంట్ రిసీవ్డ్. ఎస్, అక్నాలెడ్జ్మెంట్ రిసీవ్ కాలేదంటే k=k+1, k max ఆర్ ఎస్. నో, k నెంబర్ ఆఫ్ అటెంప్ట్స్. నెంబర్ ఆఫ్ అటెంప్ట్స్. TP maximum propagation time. TB back of time. Types of CMS access. Types of CSMA access modes. There are 4 types of access models available in CSMA. It is also referred as 4 different types of CSMA protocols which dedicated the time to start sending the data across the shared media. 1. Persistent. It sends the shared channel first and delivers the data right away if the channel is idle. If not, it must wait and continuously track for a channel to become idle and the broadcast the frame without condition as soon as it does. It is an aggressive transmission algorithm. Non-persistent. It first accesses the channel before transmitting the data. If the channel is idle, the node transmits data right away. If not, the station must wait for an arbitrary amount of time, not continuously, and when it is discovers the channel is empty, it sends the frame. Persistent. If the consistency of the one persistent and non-persistent mode combined, each node observes the channel in the one persistent mode, and if the channel is idle, it sends a frame with a p probability. If the data is not transferred, the frame restarts with the following time in slots after waiting for a q = 1 - p probability random time. O persistence. A supervisionary node gives each node a transmission order. Nodes wait for their time slot according to their allocated transmission sequence when the transmission medium is idle. Advantage of CSMA: increases efficiency. CSMA carrier sends multiple access, ensures the only one device communication on the network at the time, reducing collisions and improving the network efficiency. Simplicity. Carrier sense multiple access is a simple protocol that is easy to implement and does not require complex hardware or software. Flexibility. CSMA is a flexible protocol that can be used in a wide range of network environments, including wired and wireless networks. Low cost. CSMA does not require an expensive hardware or software, making it a cost efficient solution for a networking communications. Disadvantages of CSMA: carrier sense multiple access, limited scalability. CSMS is not a scalable protocol and can become ineffective as the number of devices on the network increases. Delay. If the busy networks are requirements to the sense the medium and wait for an available channel can result in delays and increases latency. Limited reliability. CSMA can be affected by an interference, noise, and other factors, resulting in unreliable communication. Vulnerable to attack. CSMA can be vulnerable to certain types of attacks such as jamming and denial of service attacks, which can be disrupt network communication. Comparison of various protocols. Comparison of various protocols. Protocols: transmission behavior, collision detection method, efficiency, use cases. Pure aloha sends frames immediately. Collision వచ్చేసి no collision detection. Efficiency low traffic networks. Slaughter sends frames at a specific time slots. No collision detected, better than pure aloha. Low traffic networks. CSMA or CD monitors the medium after sending a frame, retransmits if necessary. Okay. Collision detection by monitoring transformation. High efficiency. High wired networks with the moderate to high traffic. CSMA collision avoidance. Carriers and multiple access monitors medium while transmitting, adjust behavior to avoid collisions. Collision avoidance through the random back of time intervals. High wireless networks with moderate to high traffic and high error rates. In conclusion, carrier sense multiple access CSMA is a method used by devices in a network to share a communication channel without causing too many conclusions. It works by having each devices listen to the channel before sending data. CSMAs or CD collision detection is mostly used in a wired network like Ethernet. It is listens for a collisions during transmission, and if the collision happens, the devices stop sending, wait and try again. CSMA or CA collision device is commonly used in a wireless networks like Wi-Fi. It focuses on preventing collisions before they happen by having devices wait for a random times on sending signals before transmitting time. ఓకే. కొలిజన్ డిటెక్షన్ ఏముంది, అది ఈథర్నెట్ లాంటి వాటిలో యూజ్ చేస్తారు. కొలిజన్స్ ఏమైనా జరుగుతున్నాయా అనే దాన్ని కనుక్కుంటా, వింటే అది కొలిజన్ జరిగిందా లేదా అని తెలుసుకుంటుంది కొలిజన్ డిటెక్షన్. కొలిజన్ అవాయిడెన్స్ ఏం చేస్తుంది, ర్యాండమ్ టైంలో సిగ్నల్స్ని పంపించడం మొదలు పెడుతుంది, కాబట్టి అది కొలిజన్స్ని అవాయిడ్ చేస్తుంది.
Hello everyone, welcome to the course of computer networks specifically for the GATE purpose. In this lecture we will talk about CSMA CA. In the last lecture we discussed CSMA CD, that is collision detection, but here we will discuss about the collision avoidance. Okay, let's see what we will cover in this lecture. I will introduce you with CSMA CA, and then we will see the working of CSMA CA, and then we will see, okay, what is the problem with the CSMA CA. Is there any problem with the working with this protocol? Okay, let's start with the introduction with CSMA CA. Here CSMA, we know that CSMA stands for carrier sense multiple access, means sensing the carrier. That is sensed by multiple stations. Actually, multiple stations are there on the carrier, and here we are performing collision avoidance. In the last lecture, we discussed about collision detection. Rather than detecting the collision after it occurs, it's better to avoid that earlier. Rather than detecting it and then taking the measures, it's better to avoid that actually. Here, so we will talk about the collision avoidance, how we can avoid that. Okay, let's see some of the important points about CSMA CA. another important point about CSMA is it is a network protocol, yes we know, that used to avoid a collision rather than allowing it to occur, and it does not deal with the this point is important, does not deal with the recovery of the frame after a collision. So here in this protocol CSMA collision avoidance, we will try to avoid a collision. Okay, and let's suppose collision still occur. We try to avoid it, but still collision occur. Then if collision occur, we will not do anything to recover the frame. See, it does not deal with the recovery of the frame after a collision. Okay. CSMA, another important point about CSMA CA is used in wireless network, that is 802.11 Ethernet is used in wireless network. CSMA CD cannot be used in wireless network actually. Actually, the reason is why CSMA CD cannot be used in wireless network, because in wireless network the level of the energy is lower as compared to wired network. In wired network, if collision occur, then almost double energy is produced, double signal is produced, and all the station can detect that double signal and they can find that okay, some collision has occurred. But in wireless network, if collision occur, then very small signal, extra signal is generated, and that cannot be actually detected by the different stations and verified that okay, collision is occurring. So here, so that's why in wireless network we do not use actually CSMA CD. We use CSMA CA. We try to just avoid the collision. We do not detect it. Actually, we cannot detect in wireless. In wireless system, we cannot detect the collision even if the collision is occurring, because the level of the signal of collision is very low. Okay. Let's take another point. CSMA CD cannot be used in wireless network. Okay, we have discussed this thing, because collision signal increase only by 5 to 10%. Collision signal increase only by 5 to 10% in wireless network. That's why we do not use CSMA CD in wireless network. But in the case of wired network, the collision signal is almost double in wired network. That's why CSMA CD is used in wired network. Their detection of the collision is easier. Okay, but here is not possible in the case of wireless. So in wireless network we use CSMA CA. Okay, let's move on. Next point is the efficiency of CSMA CA is similar to CSMA. We have already covered CSMA, so that is having the same efficiency as CSMA CA. Okay, let's move on. Let's see now the working of the CSMA CA. How CSMA CA works. Okay, this is the first point. These 2 points shows the working of the CSMA CA. Let's read the first point first. In the CSMA CA, nodes attempt to avoid collision by beginning the transmission only after the channel is sensed to be idle. Means no other node is transmitting at the same time. Actually, this is what we are doing in CSMA and even in CSMA CD also. But in CSMA CD, we were detecting the collision. Here we are not detecting it. What we are doing here is, this is the channel, this is the station. Station sense this channel. If the channel is free, then okay, to avoid the collision, the station is sensing the channel. That's it. Okay, and if the channel is free, that is transmitting the signal. Okay, okay. So this is how actually CSMA CA is working. But if some collision is occurring, then this station do not do anything actually in that case. Okay, I will tell you how this station will retransmit the data if some frame is lost in between. Okay, and make sure that this channel is wireless channel. Okay, wireless channel. You can represent it like this actually. Maybe this is the station, and that is sending the signal to some wireless channel, maybe some satellite. Okay. So simple. That is sensing the channel. If there is no signal over the channel, over the bandwidth, in the case of wireless, actually you check particular bandwidth. If there is no signal in that bandwidth, then that system will transmit the data. Okay, let's check the second point now. If the channel is not clear, if this bandwidth is busy, then the node waits for a random period of time. The node will wait for random period of time. Then check again to see if the channel is clear. This period of time, this random period of time is called backoff factor. Just somewhat similar to CSMA CD. And here actually this station is waiting for random amount of time. If he find out that okay, channel is busy, that will wait for random amount of time, and that time actually is known as backoff factor. That is decided by actually backoff factor. Just similar as the backoff algorithm actually. Okay, so this is the basic working of the CSMA CA. I'm repeating the same thing. That will sense the channel. If the channel is free, that will transmit the frame. Okay, but here the channel is wireless channel. Second thing is, let's suppose channel is busy. If channel is busy, the station will wait for some time and then retransmit then transmit the frame. And that period of time, this random waiting period of time is known as backoff factor. Okay. Let me clear the board first and then move on. Now let me show you some frame transmission strategy. CSMA frame transmission strategies means how CSMA CA transmit the frame. That follow different strategies to transmit the frame. These are the 3 different strategies used by CSMA CD to transmit the frame. Okay, first one is inter-frame space. What is that? When a station finds the channel busy, it waits for a period of time. We know this thing, and this is known as actually inter-frame space time, IFS time. This is known as IFS time, inter-frame space time. Inter-frame space can also be used to define the priority of stations or a frame. Higher the IFS, lower is the priority. Higher is the IFS, lower the priority. What it means is that actually this is just simply showing this point actually. This point. Okay, this is showing how I have explained this point here, but I added some more information here. Actually, we can transmit the frame in different way, either waiting random amount of time, or either based upon the contention window. I can wait to transmit the frame, or I can wait for the acknowledgement based upon acknowledgement. I'm transmitting the frame. So these are the 3 different strategies to transmit the frame. Actually, this strategy is actually this one I have already discussed. But here is I have provided a particular name and I did some more information in it. Let me explain this one. Actually, this is same as this one. The frame is actually. Actually, the station is finding the channel busy. We know that will wait some random amount of time. That will wait for some random amount of time, and that is nothing just IFS time. Okay, interframe space, interframe space time. Okay, and this interframe space time can also be used to set the priority of the stations. Means I can give more priority to one station and less priority to other. So how I will decide that? Okay, if a station need to wait longer, that means that is having lower priority, and if the IFS time this time is lower for a station, means that higher priority, means that can send earlier data. Okay, that can send the frame earlier than others because its IFS time is less. Okay, so these are just simple strategies to send the frame, transmit the frame. Second one is contention window. It is the amount of time divided into slots. Each station is ready to send frames chosen from random number slot as wait time. Okay, just similar as contention window we used in CS and SCD. Here also, based upon that random number, actually different slots of the waiting time is selected. Here also, just similar as CS and SCD contention window. Okay, here we choose a random number, and based upon that waiting time is selected. Okay, waiting time of the frame is selected, and after that waiting time frame is transmitted. Okay, third one is based upon acknowledgement. Okay, the positive acknowledgement and the timeout timer help to guarantee successful transmission of the frame. In this actually in the CS and SCD we use the concept of acknowledgement because we are using actually wireless system. In the wired system we do not use the acknowledgement actually, but in the wireless we use the acknowledgement. This makes sure that okay, frame has been received at the end point. Okay, let's move on. This was the working of the CS and SCA. Now let's check out the problem with CS and SCA. The problem in a wireless network, there may be an issue known as hidden node problem. This problem may occur in CSMA CA. What this problem is, let me explain you. Hidden node problem. Okay, see, well, let's try to understand with this diagram actually. What is hidden node problem? Okay, here is station A, here is station B, here is station C. Okay, this is the wireless network of this one. This is the wireless network of A station. Okay, so you can see A and B are in the same network. A and B are in the same network. So this is the network of A, and in this network B is also there. Okay, and this is the network of C. This is the network in which C is there. Okay, and means C can access the information up to this position. Okay, he knows about different nodes up to this location, up to this area. Okay, he has the information about up to this area. C is having up to information up to this area. Now here you can note that both A and C know about the B node. A think that B is in its area, wireless area, and C also think that B is in its wireless area. Okay, so based upon that actually A will check that okay, the channel is free or not, and that will transmit the frame to B. Okay, at the same time C will check its area and will transmit the frame to B. Actually both A and B are transmitting the frame to B. They think that B is free. At the same time they think that B station is free to receive the frame. They take the decision actually based upon their own area only. Okay, so actually this may cause the problem of collision. Maybe the frame sent by A and B may collide here, may cause the collision. So actually the problem, what is the problem here is that A actually don't know that C is going to send the frame. C don't know that A is going to send the frame. Why C don't know that A is sending the frame? Why C is not able to detect this frame? And why A is not able to detect C frame? Because they are in different areas. This frame is in C area. This frame is in A area. So that's why A is not able to detect C frame and C is not able to detect A frame on the channel. And later they goes to the collision. And this problem is known as hidden node problem. Means C is hidden from A and A is hidden from C. Because A can see only these nodes which are in this area. C can see, C node can see only the node which are in this area, and A can see only the node which are in this area. So even though C is sending the data, A cannot find out it, A cannot detect it. Okay, and so C is hidden for A and A is hidden for C. That's why this problem is known as hidden node problem. A station not able to see that okay, some other station is transmitting the data. Okay, that can see in its area only. Okay, if anybody is transmitting the data. If any node is transmitting the data, then that will restrain to transmit data. But actually A don't know about C, so and C don't know about A. Both are hidden to each other, and but both B is visible to both of them, so they will transmit data to B. Okay, they will transmit data to B, but they cannot see the frame sent by A. C cannot see the frame sent by A cannot see the frame sent by C. So that's why collision will occur here. Okay, so that's the problem with CSMSCA. Okay, and what's the solution for this problem? Let me share the solution for this problem. The solution for hidden node problem is request to send. What this solution is request to send means B will first send the request, then only A will transmit. Similarly, B will send the request to C, then only C will transmit the frame. So what is the benefit of sending the request? Actually, B will send request to either A or C, not both of them. Okay, if B is sending request to A, then only A will transmit the data to B, and if B is sending request to C, then only C will transmit frame to the B. So both will not send the frame at the same time. Why? Because first they will wait for the request to send, request from B to send the frame. Okay, that's it. Request to send may optimally be used to elevate the problem of hidden node because the access point may issue a request. This is the access point. May issue a request to send one node at a time. Okay, that this access node will send the request to any of the nodes, any one node, not both of them. So that's why this thing can solve the problem of hidden node problem in CSMA CA. Okay, let's move on. Okay, that's it about this lecture. Thank you.